Hello everyone, welcome back to another question from maths problem solving. Today we're going to be doing another algebra related question from an Olympiad. It's a very interesting question, so let's get into it. Three positive integers have the sum of 25 and the product of 360. And we need to find all possible triples of these integers. So a plus b plus c equals 25. These are the three integers. Let them be a, b, and c. And a times b times c equals 360. Okay, so one method which we could use is trial and error, but this is a really bad method, so we're going to be doing sophisticated trial and error. So 360, let's just do the prime factor decomposition of this to the side over here. So 2 times 180, and this can be broken up into 2 and 90. 90 can be broken up in 9 and 10, and 9 is 3 squared, so that's another 2 3 times, and another 2 term, and another 5 term. So therefore 360 equals 2 cubed times 3 squared times 5. So now these three numbers have to multiply to give 360. And another way of saying that is they have to multiply to give this number. So let's just write these numbers over here like this. Okay, so these numbers are a, b, and c. So since they have to multiply to, since they have to add to give 25, we have some limitations. So one of the numbers can't be greater than 25, obviously, since the other two would have to be 0 or negative, and yeah, we don't want to go there. So let's start with this term, the first term. Now, this has to have a multiple of 5 in it. One of these numbers has to have a multiple of 5 in it. Let's just say it's the first one. So it can either have 5, or 10, or 15, or 20. It can't have 25 for the reasons which we just discussed. It has to have one of these. And any set of numbers which multiply and add to give 25 and 360 will have one of these four possible values in it. Since there aren't any negatives, it has to have one of these four. So now we can work the other two numbers from this value. It's from these values. So let's just write these above over here. 5, 10, 15, and 20. So let's take this number to be 5 first of all. So now these two numbers, let this number equal c for example, and this b and this a. So now a plus b equals 20. Because remember, c plus b plus a equals 25. Therefore a plus b has to equal 20. And now a times b equals 360 divided by 5, which is 72. So now this is a quadratic. So because we can write this as, since a plus b has to equal 20 and a times b equals 72, so we can write this in the form of a squared minus 20 plus 72 equals 0. Since, remember, the product is minus 20, is 20, sorry, and the sum is 72. So the reason why I'm writing this as minus is so the solutions will be positive, but I think for simplicity I'll just write it as plus 20. Now the solutions for this are, we can't really see any obvious factorizations of 72 and 20, and if we use the quadratic formula, we can use the quadratic formula to prove that there won't be any integer solutions for a, and a, b, and c are all integers, and if a isn't an integer, then that isn't a valid solution. Therefore 5 is not valid. So let's just rub all this out, and then we'll repeat this process for 10, 15, and 20. So let's just cross this out, And now let's try if c equals 10. So now a plus b equals 15, because 25 minus 10, and a times b equals 36, because 360 divided by 10. So now let's just write this as another quadratic. So a squared plus 15a plus 36. And again, if it isn't clear why we're writing these as quadratics, the reason why is because quadratics basically solve if two numbers add to give a certain number and multiply for another number. And yeah, so basically a squared plus 15a plus 36 equals 0. So a solution to this is 12 and 3. So a squared plus 3a plus 12a equals plus 36 equals 0. And now this will nicely factorize a plus 3 and a plus 12 equals 0. So now obviously these solutions will give us a equals minus 3 or minus 12, and that isn't what we're really after. So this essentially gives us that one of a or b equals 3 and the other equals 12. So therefore we have a valid solution. A equals 3 and b equals 12. Or vice versa, but that won't give us a unique set. So that is one possible solution. So let's just write that over here. So for 10, c equals 10. And when c equals 10, let's say b equals 12 and a equals 3. In reality, it's like this. So let's just write it like that. That is one possible solution set. So we can add a tick next to 10, and now let's go through the other two terms. So let's just rub all this out and go through it for 15 and 20. So let's rub all this out. Now when c equals 15, a plus b equals 10. 25 minus 15, remember? I hope you're getting used to this now. And a times b equals 360 divided by 15, which is 24. So now again, let's write this as a quadratic. A squared plus 10a plus 24 equals 0. And now the two solutions are 6 and 4. So let's write this a squared plus 6a plus 4a plus 24 equals 0. And I'm just going to skip a few steps and get to this. A plus 6, a plus 4 equals 0. So therefore another solution set is when a is 6 and b is 4, or vice versa. So 6 and 4. So let's just write that over here. So when c equals 15, b equals 6, and a equals 4, and we can write this as this. Okay, so now we have two of these. Now the final one which we'll have to test this with is 20. So let's just rub all of this out and try this process again with 20. So when c equals 20, a plus b equals 5. Remember 25 minus 20, and a times b equals 360 divided by 20, which is going to equal 18. Okay, so we don't really need to solve this. We don't need to put this in the terms of quadratics, since it's quite clear that no two numbers will add to give 5 and multiply to give 18, but just for completion, let's just write this like this. Plus 18 equals 0. Now this quadratic will have no integer solutions, therefore 20 will not be a valid solution. So yeah, that's basically the end of the question. Since remember, all of these possible numbers have to have either 5, 10, 15 or 20. And we've gone through all of them, and the only ones which give integer solutions are these two. This one over here and this one over here. So there are 4 possible values sets over here. And yeah, that's the end of the question. So I really hope you enjoyed watching this video. This is a really unique and fun question to try out. And yeah, I hope you learned a different way of thinking about just these questions which appear to be trial and error, but in reality you can use quadratics, and yeah, this just goes to show how many use cases quadratic equations really have. And yeah, they're really quite nice. So if you enjoyed this video, please, a like and subscription would be very much appreciated. And you can feel free to watch another video, which will appear in the end screen shortly. And yeah, see you in the next video. Bye.